We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello, my name is Hiren Patel, working as Assistant Professor in Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. So in previous lecture, we have seen that the different multiple evaporator system, how it is work and where it is used. So this video continues with the previous one. So we will going to see next remaining systems in this lecture. So starting with the multiple evaporator at different temperature with individual compressor and multiple expansion valve. So in last system we have seen that is multiple evaporator at different temperature with individual compressor and individual expansion valve. So that system is utilized when the different products are stored at different temperature, but the temperature requirement is not much less. This system is used where the temperature requirement is less. So here in evaporator where the refrigerating effect generated is very less compared to last system. So when there is a requirement of higher temperature range, or we can say more temperature difference between the evaporator input and output, then this type of system is utilized. So here 12 to 1, that is the temperature range between for the evaporator 1, and between 8 to 3 is the temperature range for evaporator 2, and 8 to 5 that is for evaporator 3. Also same as previous systems, there are different load for every evaporator and different mass for every evaporator. The main thing and main difference is that every mass is passing from the expansion valve. So ME1 is passing from the 3 of the expansion valve, ME2 is passing from the 2 expansion valve, and ME3 is just from the single expansion valve. In previous systems, that is in last lecture, we have seen that the individual expansion valve are there here, here and here. So every mass is passing from the one and only single expansion valve, but in this case mass is passing from the different expansion valve. So if we go for the analysis, then Me1 is the mass, or M1, that is the mass of the refrigerant that is circulated through evaporator 1, that is 210 Q1 divided by H1 minus H12. M2 is the mass that is circulated through the second evaporator, but here with that liquid refrigerant some amount of vapor refrigerant is also circulated, that is the vapor generated by the Me1, that is passing from the expansion valve 2 also here. So Me1 and Me2 both are passing from the E2. So vapor that is generated by Me2, that is already calculated in M2, but the vapor that is generated by Me1, that is M2 dash. So M2 dash will be Me1 into x10 divided by 1 minus x10. So this is the mass of vapor that is generated by the M1. So total Me2, that is Same as for third evaporator, M3 will be 210Q3 divided by H5 minus H8, and in addition there is M3 dash, that is the vapor generated by Me1 and Me2. So that is Me1 plus Me2 into X8 divided by 1 minus X8, and total Me3 will be M3 plus M3 dash. So that are the different masses passing or circulated through the different evaporators. So total mass will be Me1 plus Me2 plus Me3, and total work done will be Me1 into H2 minus H1 plus Me2 H4 minus H3 and Me3 H6 minus H5. So here the enthalpy differences. So refrigerating effect is same as 210 Q1 plus Q2 plus Q3, and COP will remain same, that is RE by W, that is refrigerating effect divided by work done. So this will be COP. So this system is utilized when temperature requirement is lower. Next system is multiple evaporator at different temperature with compound compressor, individual expansor valve. So instead of having individual compressor, here what happens, the compression process is done in the stages. So the compression will be compound manner. So here we can see that the refrigerant that is coming from the evaporator 1, that is first compressed in C1, and that is mixed with the refrigerant that is coming out from the evaporator 2, and then it is compressed in C2, and then this refrigerant after compression mixes with the refrigerant coming out from the evaporator 3, and then after mixing they will be compressed in compressor 3 and then circulated through the condenser. So here load are different, that is Q1, Q2 and Q3. Each evaporator has individual expansion valve here. So the no flash generation, so no flash is transferred from the other evaporator. So here in pH chart we can see that 1 to 2 is first compression, then 2 to 4 that is mixing, 4 to 5 again compression, 5 to 7 mixing, and 7 to 8 is again compression. Here the refrigerant that is supplied to each and every evaporator is at same temperature. So if we go for the analysis, the mass M1 that will be circulated through the evaporator 1, mass M2 that will be circulated through the second evaporator, and mass M3 that will be circulated through the third evaporator. So that is M1, M2 and M3. So if we go for the second evaporator, then M1 plus M2 into H4 that is equal to M1 H2 plus M2 H3. So if we apply the heat balance at second compressor inlet set point 4, then we are having H4 by this equation, that is equal to M1H2 plus M2H3 divided by M1 plus M2. So as same manner we can also find out the H7. So total mass here, that is M1 and M2. So here at 4 M1 plus M2 into H4, and here at 7 M1 plus M2 plus M3. into H7. So same, by applying the heat balance, we can find out the H7, that is M1 plus M2 into H5 plus M3 H6, that is supplied from here, because here M1 plus M2 is already there, into H5 plus this is M3 into H6, and that is equal to M1 plus M2 plus M3 H7. So we can find out the H7 enthalpy from this equation. Other enthalpies can be calculated from the pH chart. So from that, work done will be M1 H2 minus H1 plus M2, sorry, instead of M2 it will be M1 plus M2, because both masses are passing from the second compressor, into H5 minus H4 plus M1 plus M2 plus M3 into H8 minus H7. So that will be our work done, and COP will remain same, that is refrigerating effect divided by work done. So this is the multiple evaporator at different temperature with compound compression and individual expansion valve system. Next system is multiple evaporator at different temperature with compound compressor, individual expansion valve, but in additional there is a flash chamber, sorry, flash intercoolers. So here there are two flash intercoolers, F1 and F2. We are having 3 evaporators with load Q1, Q2 and Q3, having 3 different expansion valves. So here what happens, after compression in first compressor, the refrigerant passing from the flash intercooler, where the flash generated from the expansion of E2, that is directly circulated into the compressor, and only liquid refrigerant is transferred to the evaporator, second evaporator. Same as in third compressor and third evaporator, only liquid is transferred from the evaporator, and flash that is generated from E3, that is directly transferred to the compressor. So if we see on pH chart here, the supply of refrigerant to the compressor, that is saturated vapor only. So benefit of this refrigeration system is that the compressor has to do less work compared to previous system, so the size of compressor can be reduced, so ultimately the initial cost can be reduced. So if we go for the mass, so here it is written MC1. So what it means, that we are calculating mass for the compressor instead of evaporators. Previously we have calculated mass for the evaporator, that is circulated through evaporator, but here the mass of refrigerant that should be compressed in compressor. So MC1, that is M1, is equal to 210Q divided by H1 minus H10. M2, that is 210Q2 divided by H3 minus H9, that is circulated through evaporator, and the flash that is generated into the flash intercooler, that is M2 dash. So total mass of refrigerant that is handled by the second compressor, that is MC1 plus M2 dash. So MC1, that is the mass coming from the first compressor, M2 that is coming from the evaporator, second evaporator, and M2 dash that is the generated flash into the flash intercooler F1. So here if we see that is MC1, M2 dash and M2. So same as for M3. So MC3 that is MC2 plus M3 plus M3 dash, and same for the work done. So W will be MC1 H2 minus H1 plus MC2 H4 minus H3 plus MC3 H6 minus H5, and COP that is refrigerating effect divided by work done, and refrigerating effect is 210 Q1 plus Q2 plus Q3. So this is the system which utilizing the flash intercoolers, and benefit of that is the size of the compressor can be reduced. Now next system is multiple evaporator at different temperature with compound compressor, multiple expansion valve and flash intercooler. So instead of having individual expansion valve, here the multiple expansion valve means the mass that is circulated through evaporator 1 has to pass from the every expansion valve. So here same as 3 evaporators at 3 different load, Q1, Q2, Q3, 3 compressors C1, C2 and C3, and 2 flash intercoolers F1, F2, 3 expansion valve E1, E2 and E3. So if we see the pH chart here, the refrigerant that is entering to every compressor is saturated vapor, and the refrigerant that is entering to the expansion valve is saturated liquid. So every time when refrigerant is forwarded, it is just in liquid state. So after 8, the mass that is mass of refrigerant that is circulated through evaporator 3 that is in liquid form, and the flash is transferred to the compressor. Same as whatever the mass that is transferred from the expansion valve 2 that is in saturated liquid state. So if we see for the analysis, then here also we are calculating the mass for the compressor that compressor need to be handled, that is MC1 is equal to M1 210 Q1 upon H1 minus H12. Here 2 additional mass that need to be calculated. So the first mass that is M2 dash. M2 will be 210 Q2 H3 minus H10, that is the mass of liquid refrigerant passing from the evaporator to M2 dash, that is the vapor generated by the mass after expanding inside the expansion valve 2, and that is directly circulated to second compressor, that is M2 dash here, and M2 double dash will be the mass, that is the mass circulated through the first compressor that is also expanded in second expansion valve, and at that time during the expansion it is also generating the vapor, and that vapor is calculated as M2 double dash, and it has some dryness fraction. Here we can see that at X8, so sorry at X10. So here M2 double dash is equal to MC1 into X10 divided by 1 minus X10. So total mass that need to be handled by second compressor is MC1 plus M2 dash plus M2 double dash, and same occurs for M3, that is for the compressor 3, that is M3 is equal to 210Q3 H5 minus H8, that is the mass circulated through third evaporator. M3 dash, that is the vapor generated by M3 passing from the flash intercooler, and M3 double dash, that is the vapor generated by the mass MC2 during the expansion into the expansion valve 3. So total MC3 will be equal to MC2 plus M3 dash plus M3 double dash. So this is the total mass that need to be handled by the third compressor. So same as W will be MC1 H2 minus H1 plus MC2 H4 minus H3 plus MC3 H6 minus H5, and refrigerating is equal to 210 Q1 plus Q2 plus Q3, and COP is equal to refrigerating effect by work done. So total mass M will be equal to MC1 plus MC2 plus MC3. So these are the different kind of multiple evaporator systems that are used for the handling the different mass at different temperature, or different products at different temperature and different requirements. So this is it for the multiple evaporator system. Thank you for watching.